All right, guys, so what we're going to be doing today is we're doing an intro to logarithms. All right, so here's what I want you to do just to start things out. I want you to go to Desmos right now. Go to Desmos, and I want you to type in one of the most basic exponential functions known to humanity, which is y equals 2 to the power, where's that? There is to the power of x, because we just finished up with exponential functions, okay? But we've talked about inverses before. But we've not talked about inverses to exponential functions. Well, here's what I need you to know. I need you to know that the inverse to this y equals 2 to the power of x is known as a logarithm. Y equals, now this is where you need to go. Check this out. Go to functions. Go to miscellaneous. Do you see where it says log base a? Hit that baby right there. Type in a 2 and then type in an x. Because I need you guys to understand. What do we know about inverses? They always reflect across y equals x, and these are inverses of each other, okay? Y equals 2 to the power of x is the inverse of y equals log base 2 to the power of x. So logarithms are inverses of what type of function? They're inverses of exponential functions. That's the whole purpose of having logarithms, okay? And we're going to learn how to use them and their properties. It's going to be super, super important. So what I'd like you to do right now on your paper is we're going to write one of the most basic understandings of an exponent. I'd like you to write 2 to the power of 3 equals 8. 2 to the power of 3 equals 8. Now, this is in this form. You guys ready? This is in the form of b to the power of x is equal to y. b raised to the power of x is equal to y. Well, if I wanted to convert this, remember, this is in what form? Form of an exponent. So I'm going to call it exponential form. But I want to change it from exponential form to what's called logarithmic form. Logarithmic form. And watch what I do. I'm going to put log base 2, 8 equals 3. This is the form that you would have it in. So if we're using this, we would say log base x, it's not base x, silly me, it's base b, duh, base b, put y equals x. And I want you guys to teach you something called, I like to call the around the world method. If I want to go from logarithmic form to exponential form, here's what I do. I go 2 raised to the power of 3 has to equal 8. So 2 raised to the power of 3 has to equal 8 in order for that to work. Just like base b raised to the power of x is equal to my y value. So that's a very important procedure, knowing how to go from exponential form to logarithmic form and back and forth. So this is something you definitely need to have written down in your journal. All right, so what we're going to do right now is we're going to go over here to this intro of logarithms. We're going to go down here. All right, and I want you guys to see right here. Do you see right here where it says 2 to the power of 4 equals 16? So you could use this. Here's another example of I can go 2 to the power of 4 is equal to 16. So this is in what type of form, everybody? That's in exponential form. This is in logarithmic form. All right, so we're going to do a few examples real quick. If this makes more sense to you, you're more than welcome to write this down right here. All right, it's the same process. B to the power of C is equal to A. All right, so you could use that if you'd like. You can also see right here that same method, 2 to the power of 3 equals 8. 3 to the power of 4 equals 81. 5 to the power of 2 equals 25. So these are all in logarithmic form. These are all in exponential form. So you can see that pattern being used over and over and over again. So if you like this example better, you're more than welcome to go from here to here. So we're going to go ahead and do a couple of examples real quick. Here we go. Let's look at this problem. Right here, which one would match up? We know 2 to the power of 5 is 32. Which one matches up where you go 2 to the power of 5 equals 32? A, right? A is the only one that works. What is this saying? It's saying what? 5 to the power of 32 is equal to 2. That's not true. What is this one saying? 32 raised to the power of 2, or 32 squared, is equal to 5. Well, that's totally incorrect. So that's why this would be your answer. All right? Which one right here? What's our base? Our base has to be base 5. What are we raising it to? To the power of 3. Can you guys see this B would have to be the one that works if you go around the world? 5 raised to the power of 3 equals 125. Ooh, we have to write something now. In what form? Exponential. So how would I write this in exponential form? How would I write that? 2 to the power of what? 6 is equal to 64. All right? Let me make sure I close that. Don't need that. All right. So right here, I'm going to type in 2. I'm going to raise it to the power of 6, and I'm going to set it equal to 64. All right. What about this one? What are we going to? What will I write that would be correct? What do y'all think? Yeah, 4 to the power of 2 equals 16. Oh, not 15, 16. That'd be bad. All right. All right, so what we're going to do, this is just an introduction. What we're going to do right now is I'm going to go over here to evaluating it. And here we're going to do 4 problems, and I just want you guys to see what you would do by hand. So listen up. I want you guys to write down log base 4 of 4 and just set that equal to x. So whatever this is, just set equal to x. That's what I want you to do. And then I want you to go around the world. Ready? 4 to the power of x equals 4. So right, 4 to the power of x equals 4. And then wherever you have right here, put the exponent 1. So what would the x value have to equal in order to make this statement true? What do you guys think? 1, you're right. So right here, we just put a 1. All right, guys, something I want you to write down in your journal. This is a very, very, very important rule. It's a special rule of logarithms. Write this down. Ready? Log base b of b to the power of x equals x every single time. Write this down. It's very important. Here we go. Log base 5. If I say 5 to the power of 1, 2, 3, what would the answer be? 1, 2, 3. This is a very, very important rule that if you have the same base, whatever that power is, it will end up being your answer every single time. All right? I gave on a final one time this. Log base 5 to the power of 5. And I wrote I, H, A, T, E, M, A, T, H. And all the student had to write down on their paper was I hate math, and they would have gotten it right. And usually the people that got it wrong were all the people who hated math. But the people who didn't hate math were the ones that got it right. It was really weird. Okay? But understand, whatever this power is will be your answer. Okay? All right. Okay, guys. Next one. Log base 6, 36. What am I going to set it equal to? X. 6 to the power of what equals 36? Dose, right? So if I said 6 squared, does 6 squared equal 6 squared? If I change 36 to the power of 6, yes, 2 equals 2. So yes, 6 squared equals 36. So all I got to do is put a 2. 6 squared is 36. All right, so those are pretty easy. I mean, when I say easy, it's like they can't really get any easier. Now this one's a little bit harder. Okay? We have what? If we want to change it to exponential form, we're going to go 3 to the power of what? 3 to the power of x equals 729. So basically, what do we got to figure out? We got to figure out 3 to what power is 729. Okay? So does everybody know, like your 3s? We know it's not what? 3 cubed. 3 to the power of 4 is 81. 3 to the power of 4 is 243. So I'm guessing 3 to the, not 6 to the power of 3, my bad. I'm guessing 3 to the power of 6 is 729. So what would our answer be? Our answer would be 6. So yes, we are starting off easy, but then we are going to get to a little bit more difficulty. So here's what we're going to do. So I want you guys to evaluate Logarithms Advanced. I'm going to pause this video real quick while my students write this next part down. The first one's easy. This one's going to be a little bit more difficult, but not too bad. So I need you guys to write down 16 to the power of x equals 4. 16 to the power of x equals 4. And what we need to do is we need to change the 16 to 4 squared. All right, so what I've done here is I've taken this number 16 and I've changed it to 4 squared. And I've changed 4 and I've made it 4 to the power of 1. Now, in an exponential equation, if the bases are the same, you're allowed to set this exponent equal to this exponent. So I'm allowed to set 2x equal to a 1 only because I changed it to the exact same base. What's our base that we're working with? A base 4 instead of a base 16. So what is our x going to have to equal if we divide both sides by 2? X equals a half. So that was our first one. The first one's going to be 1 divided by 2. All right, next one I want you guys to write down with me is this one right here. We're going to do 4 of these. So you see the pattern. So right now, the first thing I want you to do is I want you to set this equal to x. And you're going to do 2 raised to the power of x equals 1 over 64. That's the first thing you're going to do. Now, everybody, this is in base 2. So I'm going to leave it as 2 to the power of x equals 1/2 raised to a certain power. What is 1/2 raised to a certain power? Nope. If I have 2, actually it'd probably be easier if I do it this way, okay? You guys ready? Let's focus on our 2's. Okay, get me some room here. Here we go. Ready? We know 2 to the power of 1 is 2. We know 2 to the power of 2 is 4. 2 cubed is 8. 2 to the power of 4, 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. But if I work my way backwards, if I say 2 to the 0, that's 1. If I say 2 to the negative 1, that's a half. If I say 2 to the negative 2, that's negative 1/4. So what is 1 over 64 actually going to become as a base 2? If 2 to the power of 6 is 64, then I'm going to have to go all the way to what? 2 to the power of negative 6, which is 1 over 64. So I'm going to put 2 to the power of negative 6 because 1 over 64 is the same as 2 to the power of negative 6. Now that I have the same base, what does my x value become? It becomes a negative 6. That's why my answer is negative 6. So understand, your answer is either going to be a positive exponent or it could be a negative exponent. So you have to kind of know your powers, whether they be positive or whether they be negative. Okay? 2 more, and I'll let you guys go ahead and keep working on this. All right? I want to see if you guys, and I want you guys to do this without having to use any calculating device. All right? So how am I going to set this up? I'm going to set it up as what? 25 raised to the power of x equals 1 over 125. In case you're wondering what base we're working in, we're not going to be working in base 25. What base do you think I'm going to change everything to? If you had to guess. 5. So we're going to start with what? 5 squared. Why 5 squared? Because 5 squared is the same as 25. Okay, so 5 squared is 25. 5 cubed is 125. So what do you guys think 5 to the power of negative 3 would become? 1 over 125. So let me explain something real quick. All right, whenever you guys have exponents, if I say a to the power of negative 2, that's the same as saying 1 over a squared. If I say x to the power of negative 6, that's saying 1 over x to the power of 6. So negative exponents, all you got to do is make a positive, is just put them underneath the denominator. So we're going to change 25 to the power of x to 5 squared times x. All right, so we're just changing the 25 right here to 5 squared. And what am I going to change 1 over 25 to? 5 to the power of negative 3. So this 125 is being changed to 5 to the power of negative 3. Why am I having to do that? Because I got to get the same what? Same base. Now that I've done that, what can I set equal to each other? I can set the 2x equal to the what? Negative 3. So now I can set these equal to each other. And 2x equals negative 3. Divide both sides by 2. And x equals negative 3 over 2. Now, in the Khan Academy, because it's a discrete decimal, it does not go on forever. If you wanted to type in x equals or put negative 1.5, that's okay. But those are my answers that I'm going to type in. This one or this one. So I'm just going to put negative 3 divided by 2. They did it a little bit different way. All right, I like to just change it to the same base. Well, you'd have to use the calculator for that. trying to do it without a calculator. All right, last one. Write it down. Write down log base 8 of 2 equals, just set it equal to x. And just take that and raise it to a certain power. We're going to say 8 raised to the power of x equals 2. And the last thing we're going to do is we're going to change it to the same base. What base are we going to use? We're not going to use base 8. We're going to use base number 2. So how could I change 8 to a base 2? 2 cubed. So all I did right here is I took this 8, and what did I change it to? 2 cubed. Just brought down the x. Instead of a 2, I raised it to 2 to the power of 1. So what am I going to set equal to each other here? What would you guys say? Yeah, set 3x equal to the 1. Very good. So we're going to take 3x, and we're going to set it equal to 1. Divide both sides by 3. And so what's the answer I'm going to type in? 1/3. That's it. So, in review, everybody. In review, let me go back real quick. What's the number one thing you're going to have to know how to do? Change, where is it? Right here. You need to be able to know how to change it from exponential form to logarithmic form. And you need to know your basic bases of 2, 3, 4, 5. 2, 3, remember that what we put in the journal where we listed them out? 2, 3, 4, 5. Make sure you know your powers, not just positive exponents. We also need to know our negative exponents as well. So not just positive, but also negatives. And that's what I want you to be working on today. Good luck.